table of values here. We're not going to use all of it. We're going to use 2 points, and that is it, okay? The only ones we're going to look at are 0 and 1. Ignore the rest of it. It's not that it doesn't matter, but you don't need it for what you're graphing for me, okay? So the first one here, y equals 2 to the x. If I plug a 0 in for x, what do I get? 1, okay? If I plug a 1 in for x, what do I get? 2. So I am going to plot those points. Red so you can see it. Guys, if you can't see your x and y axis on your grid, go ahead and draw that in. 0, 1, 1, 2. So every single time you graph an exponential for me, you are going to start by plotting those 2 points, 0, 1, and then 1, whatever the base is. So right now we're doing base 2, so that's why I'm using 1, 2. If I change the base to 5, then you do the point 1, 5. Okay, so every single time, write those down. Those are the 2 points you're going to start with for graphing. All right, do you remember the general shape of an exponential graph? Like, what does it do? Yeah, I always see a lot of hand. Yeah, it goes that way, right? Exponential growth. Okay. So I'm going to sketch in my shape here. Is there an asymptote? Anybody remember? There definitely is. Yeah, at 0. So I'm going to go ahead and draw that. So we're not going to cross our horizontal asymptote. That right there is your parent graph for exponentials. And that's all I need. I need the 2 points, the right shape, and then your asymptote. The way we're going to graph everything is by starting with those 2 points and then doing all of your transformations. So our shifting, reflecting, stretching, all of that stuff from those 2 points. So looking at the one we just graphed, what is my domain? Good. Negative infinity to infinity. And what about the range? 0 to infinity. Do you think the 0 is included? It's not. We approach that horizontal asymptote, but we don't actually cross it this time. So 0 to infinity. And then what's the equation of my asymptote? Yeah, y equals 0. Good. All right. Let's do number 2 together. So I'm going to start with those same 2 points. I'm going to put a dot at 0, 1. And I'm going to put one at 1, 2. Okay, those 2 points every time. Then I just have to look, where am I going? So what is this x minus 3 telling me? Which way am I going? To the right 3. Okay, it's in with the exponent with the x, so that means it's going to be left or right. It's minus 3, so I know I'm going to the right 3. So for your graph, all you're going to do is take your 2 dots, count to the right 3, and put a point. It's 1, 2, 3, 1, 2, 3. Before you actually draw it, let's draw your asymptote. Did my asymptote move at all? No, I mean, it went sideways, but does that actually change anything? No, it's still right here. So then I can just sketch my graph. You guys see it okay? All right. Domain, range, and asymptote. Any change with any of those 3 from the parent? Nope, nothing changed. So it's still negative infinity to infinity, 0 to infinity, y equals 0. Okay. right, let's try number 4. I'm going to jump around a little in our notes just because we don't need to do every single one of these. So number 4. What 2 points do I start with? Everyone together, guys. What 2 points do I start with? 0, 1. 1, 2. Okay, 0, 1. 1, 2. Where am I going this time? Up 1. Okay, so just move the dot up 1. New point. New point. Does that change my asymptote? Yes, okay, good. It's got to move up 1. There it is. Then I can sketch the shape. Okay. All right, so my domain is still negative infinity to infinity. What's my range this time? Good. And what's my asymptote? 1 in the middle of a yawn over there. Y equals 1. Okay. Question on that? All right. Let's try 6 together. Down here on 6. Okay, what 2 points do I start with? 0, 1, and 1, 2. Every single time start with those, or whatever your base is. And then we'll deal with what's happening in the equation. So what do we have this time? We have a negative out in front. What is that doing? Okay, yeah, it's flipping it over the x-axis. The reason is you're taking your y values times a negative 1. That's why they flip, okay? So whenever there's a coefficient out in front of that exponential, you're just multiplying your y values by that, okay? So let's think about 0, 1 would become 0, negative 1. 1, 2 would become 1, negative 2. What about my asymptote? The same, yeah, when you flip 0 over 0, it's still 0. Now think about the shape. Make sure you're doing just the mirror image of it. So it's going to look like that. Okay. And I know the rest of my graph, it's not perfect. Okay, I don't expect perfection with these. I want you to have the 2 points showing the transformation and the approximate shape. Okay. So let's look at 7. Oh, sorry, I forgot my domain and range and all of that. So domain, are you noticing that the domain never changes? Okay. What about the range this time? Good, negative infinity to 0. Always start from the bottom and go up. Asymptote is still y equals 0. All right, number 7. Plot your 2 points, 0, 1, 1, 2. Where's the negative this time? It's in with the x, so that's different, right? What does that mean? Okay, yeah, so instead of flipping this way, I'm now flipping this way. Think about it, it's your x that changed sign. Your x's are going from positive to negative. Okay, that's all you're doing. So, is the point 0, 1 going to go anywhere? No. And 1, 2 is going to become negative 1, 2. What about my asymptote? Same, okay. And then sketch your shape. Looks like exponential decay. So those are the 4 basic transformations. It can be left or right, it can be up and down, it can be reflected over x, reflected over y. I want you to try putting a couple of these together. So let me fill this in real quick. Still 0 to infinity. Okay. try for me number 9 and number 11 and 12. I want you to do all 3 of those. If you have colors, it's helpful if you're doing multiple sets of dots, so you don't just end up with 6 penciled colored dots on your paper and you don't know what to connect to what. An order of operations matters. You should multiply before you add or subtract.
Okay, so let's look. It stayed in the exact same spot for all the stuff. That's where it went. You see up 1, so this was down 4.
So your asymptote. The asymptote goes, that's great. And then it's like, so you come down here.
Okay.
Yeah, you go left to. Right, this is 6. You can multiply. So this just means times whatever your y values are. And then those points down 5. So
I'm gonna go through. All right, guys, these 3 are the trickiest ones, so let's look at them. If you are struggling at all with these, please do it in steps. Please show all of your dots. Get some colored pencils or pens if it helps you. So 9, I'm going to start maybe with 0, 1, 1, 2, okay? All right, then I have some shifting to do. It doesn't matter shifting which one you do first, okay? I'm just going to start right here. What does x plus 2 tell me? Which way am I going? Left 2. So I'm literally counting 1, 2, put a dot. 1, 2, put a dot. I'm not done. I then have to do this minus 4. What does that mean? Down 4. Yeah, so 1, 2, 3, 4. 1, 2, 3, 4. So those are my final 2 points. What about my asymptote? Down 4, right? So guys, something that I'm hoping you noticed, whatever the vertical shift is, that is your asymptote. Okay, so if you've got a minus 4 at the end, your asymptote is y equals -4. Okay? It's always going to match that vertical shift. And then sketch your shape. Domain. Range. Good. All right, how do we feel about 9? That one's not too bad, right? Just shifting, we're okay? All right. 11 is where it gets interesting because I threw a 3 at you. So let's start 0, 1. And the base is still 1, 2. I know a couple of you multiplied the 3 and 2. With your order of operations, you can't do that because you have to do 2 to the x before you multiply. So the base is still just the 2. Okay? We definitely have to deal with the 3, but you don't get to deal with it in the very first step. What is that 3 doing? It's doing what? Sorry. Yeah, multiplying the y values by 3. It is stretching out your y values, okay? So 0, 1 is going to become 0, 3. 1, 2 is going to become 1, 6, yes. All right, so I've stretched. Then what other shift do I still have to do? Yeah, this -5 is telling me down 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the blue dots are my final ones. What about my asymptote? What's it going to be? -5. Yeah, it's going to match that vertical shift. So 1, 2, 3, 4, 5. There we go. Okay, those always match. So it looks a little different, but that's because it's been stretched out. It should be like a taller, skinnier graph. So still -infinity to infinity, -5 to infinity, and then y equals -5. Okay, I know you didn't like that one to begin with, but does it make sense now? Whenever there's that coefficient, you multiply it by the y values once you're there. All right, 12. We start with 0, 1, 1, 2. Okay, we have to deal with that negative first. That's like taking your y values times -1. Okay, so where do they end up? Yeah, they're flipped. So 0, -1, 1, -2. And then one more piece. We got to go up 3. So I just take the green dots and count. 1, 2, 3, 2, 3. Without color, this is a very confusing looking graph because you just have dots everywhere. What about your asymptote? Where's it? 3. Yeah, it's going to match the vertical shift. 1, 2, 3. All right, so sketching your shape. Remember, it's the blue dots I have to go through. This one got flipped, so that's why it looks upside down. -infinity to infinity. -infinity to 3, and y equals 3. Okay, how we doing? Give me like here, here, here. I'm hoping most of us are here, here, but we're, okay. All right. Okay. Now we're going to graph logs, but using the exact same process, okay? So go ahead, turn the page to this. All right. You do not have to be able to evaluate a log to do this, okay? Logs and exponentials are inverses of each other. Inverses mean the x and y have just been switched, okay? So if you look at my table, it's a lot like the first table, only I'm giving you the numbers now in the y instead of the x. So again, I'm only going to look at these two values. So with our exponential, we always graphed 0, 1, 1 base, right? For our logs, if all I'm doing is switching the x and y, what 2 points do you think I'm going to graph? 1, 0, and base 1. So in my chart over here, I'm going to do 1, 0. And then what is the base of this first log graph? 2. So 2, 1. You don't need to write this down, but just graphically, this is what I mean. Okay, that's your exponential graph, right? Your log graph is the inverse of that. Do you see how that's like reflected across that line, y equals x? Okay, that's all we're doing. You're using that knowledge to graph it. You're not at all like plugging points in and plotting those, okay? All right, so let's do the first one here. So we know we have the points 1, 0, maybe, and 2, 1. Okay, with exponential, we had a horizontal asymptote. What kind of asymptote do you think I'm going to have here? Vertical, yeah. So I'm going to graph this. And then you can sketch your shape. So what's the domain of this one? 0 to infinity, good. What about the range? Good. Do you guys see how that's just flipped from your domain and range from the other ones, from the exponentials? Okay. And then your asymptote, instead of y equals 0, it's going to be x equals 0. All right. So you see how this is very similar to the others? Okay. All right, so let's try number 2 together. All right, what are the 2 points I start with? Yes, thank you. I'll wait you out today, guys. 1, 0, and 2, 1. Good. Okay, where am I going? Up 1. Yeah, that's outside, so I go up 1. Up 1. What about my asymptote? Still at 0, right? Shifting that up 1 doesn't really change anything. And then you've got your shape. So, 0 to infinity. Negative infinity to infinity. X equals 0. How are we doing on that one? Yeah. Yeah, good question. So when we did the exponential, if there was a vertical shift, that changed the asymptote. Since our asymptote is now up and down, it's not going to be the vertical shift that changes it. What's it going to be? Yeah, if there's a side-to-side shift. So that's why that one's still x equals 0. So yeah, good question. So let's look at 3 and see if it changes. Okay. All right, guys, let's look at 3. What are my 2 points? Come on. 1, 0. 2, 1. Okay, good. Where am I going this time? What does this mean? Right, left, up, down, where is it? Which side? Close. It's in parentheses with the x. No, still close. So when it's with the x, it's going to go either to the left or the right. So let's look, because yeah, I want to make sure you see the difference. I've written all over them, so maybe you can't see it anymore. Do you see in number 2 how the +1 is not like connected to the x? Okay, so that's up or down. Number 3, where it's with the x in parentheses, that makes it left or right. Okay, so third time's the charm. Where's it going, guys? left 3, because remember in there's weird, it's the opposite of what it seems like it should be. Okay. 1, 2, whoop, need a pen. 1, 2, 3, and 3. All right, did the asymptote change? Yeah, sideways shifts are going to affect your asymptote now. So it went left as well. It is all the way over here at -3. Okay. So your domain is now from -3 to infinity. Range is still -infinity to infinity. Asymptote is at x equals -3. Questions on that? All right, let's look at 4. What's happening here? Got a negative, so we're flipping. Is it out in front or is it in with the x? It's out in front, right? Okay. So that's flipping over the x-axis. That's like saying -1 times your log base 2 of x. So 1, 0, 2, 1. When I flip over the x-axis, does 1, 0 go anywhere? No, because 0 times -1 is still 0. What about 2, 1? Where's that going to go? 2, -1, right? You see it? Does my asymptote change? No. Okay. So then think about the shape. It's upside down now. But your domain, range, and asymptotes are exactly the same. All right. 5, 7, 8, and 9. Those 4 you're going to try right now, okay? 5, 7, 8, and 9. And let's see how we're doing. It's just so not. Okay, so you've got a negative in x. And me, right?
I mean, this point won't change. So that's why every time start your point. Negative x. Yeah.
Next, you can divide both sides by -1, and it's still 0. Doesn't actually.
We do graphing before evaluating because I want you to just think graphically, not evaluate the law.
We're gonna work on this area out.
I think it's. I'm used to doing this.
Which is why if you can think of it just the transformation. Don't try to make people evaluate your head.
Just think about you got 2 points, and I'm doing those 2 things.
It's definitely.
Good.
Yeah. So that is taking Y values times.
Yeah, so if you start with. So if you do 0 times 3, that's still 0, right? 1 times 3, yeah. Well, this is still, so your 2 points are 1. That's what we start with. 3 times the y value. The x's stay the same.
Just like
A negative in front of a log
This one. Well, it's right here. You're like looking over it. It's like all the time the essay says what is if you actually. Otherwise. Okay. Negative x, right? One zero.
Negative 1. One is going to be times -2.
Okay.
I understand. Don't obsess about that. Okay, so negative x. Are you flipping this way? Okay, well, so that's going to be good. And the reason being, it's saying, you're welcome. Another minute here, guys, and we'll look at all 4 of those.
Yeah, so it's gonna change the X, so this is 1, 0.
So like this is the base of 2 is
So put the same 2 points together, and then take the Y value.
All right, guys, let's look. Right. So first points, 1, 0, 2, 1. All right, guys, I've had a lot of questions on number 5. This is a reflection, but if you think about the reflection, it's the X that has the negative next to it, right? So you're just doing the opposite of your X values. So 1, 0 is going to become negative 1, 0. 2, 1 is going to be negative 2, 1. Okay? Your asymptote doesn't go anywhere. So the shape of your graph is over here. It's just reflected across the y-axis this time. Does that make sense? The difference between the two negatives being out in front versus being in with the x. Out in front, your y values are changing sign. In here, it's the x's that are changing signs. Okay? All right. Domain, negative infinity. Okay. 7. Start with 1, 0. 2, 1. And then I am going left 1. Okay. And down 2. If you want to do that all in one step, I am fine with that. Your asymptote, it moves left, right? Left, right? That's confusing. So there is your final shape. So your domain is now negative 1 to infinity. Range is still all real numbers. Asymptote is x equals negative 1. Okay, you shifted it horizontally. You shifted left or right, so that's why your asymptote is going to change. Are we okay with 7? Yeah? All right. 8. I start with 1, 0, 2, 1. I have to deal with the negative in front first, which that point doesn't move. 1, 2 becomes, or I'm sorry, 2, 1 becomes 2, negative 1. Then I can move up 2. My asymptote has not gone anywhere. And I get that shape. How do we do on 8? I heard, oh shoot. Are we okay? What happened?
I gave you the thumbs up and I realized I did not get it right.
Okay. Do you see what went wrong?
Yeah.
Okay.
Yeah. How'd you get like the first shift? Like before you moved it up?
The green one?
Yeah.
So that's the negative in front. So I just took my y values times negative 1. So 1, 0 is still 1, 0. 2, 1 becomes 2, negative 1. It's that flipped over the x-axis.
So when there's a negative like in front of the log, that's when it like reverses, and then when there's like a negative in the parentheses, that's when it gets.
Exactly. Yep. All right, one more. Or do we need a minute? Sorry. I see people still writing. Okay. Maddie, you look like you still have a question.
Yeah, I don't really know what's going on, to be honest.
So number 8?
Yeah.
Okay. So the negative in front, what does that do? Or is that the question? You're like, yeah, I don't know what that does.
Yeah, does it makes one of the like X or Y values the opposite of
Yeah. So we're starting with, I'm just going to write the points, 1, 0, and 2, 1, right? Okay. A negative in front makes your Y values negative. So I can put a negative in front of 0, but does that, yeah, that doesn't do anything. But then this would become 2, negative 1. That's like the green dots, okay? Then I take those green dots and shift them up 2. I think it's hard for you guys to see the shape sometimes. Like you're doing okay with the points, but then you're like, what do I draw at the end? So you got to just visualize the original shape and what has happened. All right, one more. Let's look at 9. So I start with 1, 0, 2, 1. What is that 3 doing in front? What do you think, guys? What did you say, Preston? Okay. Does it spread your X's or your Y's? Yes, your Y's. So you're taking your Y values times 3. So the point 1, 0, 0 times 3, still 0, right? So that point doesn't actually go anywhere. What's 2, 1 going to become? Yeah, 2, 3. 2, 3. Asymptote didn't go anywhere. So your graph just got a little bit taller and skinnier. Okay? Domain, 0 to infinity. X equals 0. Questions on those? Yeah. Okay, so it was the point 1, 0. Okay? The 3, you're taking the Y value here times 3. So what's 0 times 3? So yeah, so it's the exact same. Yep. What else, guys? Okay. We don't have time to actually start 2, 3, whatever I said our other one we were going to do today was. So let's do a little bit of whiteboard practice just with the graphs, just to make sure you guys are okay. So in your desk, there should be a whiteboard and a marker. Reach around or have someone in front of you help you get that out. Yeah. Usually I'm throwing things at people and they aren't ready. Good catch. There should be, in every desk there should be one, so if you don't have one, someone probably has an extra in there. So guys, double check the desks around you, or there's, you want to check one of those empty desks? Are they ready? You need a marker? Okay. They're not a board in there? Who has an extra board? Guys, double check your desks, please. There should be 4. There you go. All right, here's on paper for now. We will find another board for next time. Okay, guys. All right, so you're just going to graph these for me. All right, let's do log base 3 x plus 2 minus 1. So once you think you've got it, hold it up, and I will check for you. Make sure you draw your asymptote. Yes. 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 Good. Yeah. Yes, 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 yes. Yeah, I can see that. Yeah, I changed the base on you here, right? But is that really that much different? Instead of the 0.21, you have 3.1? Not quite. Yes. Sorry, Owen. Yeah, it looks good. Not quite. You have things kind of upside down. And guys, you can talk to each other, help each other out with this. If you've got it and your neighbor's not quite there yet, then help each other. And that doesn't mean just show them your board and go here. Like, talk to them. Yes? Yes, much better. Good. So that's why it looks a little washed out. Does that make sense? So it's base. Then you can go on. Okay. Yes, yes. All right, guys, let me draw it. If you're not there yet, that's okay. Pay attention as I go through it. So your 2 points are going to be 1, 0, and this time 3, 1. Okay, and then I'm going to go left 2, 2, 2, and down 1. Your asymptote is over here. I went too far, didn't I? I went left 3. More. All right, guys, that's what it should have looked like. Yes? Okay. All right, I'm going to switch back to exponentials to see if you can switch in your brain. I don't know. So let's do negative 4 to the x plus 3 minus 2. I gotta think about what that's called. think back exponential. What are my 2 points that I start with? Okay. Yes. Good. Not quite. Yes. You have the worst marker ever. Yes. I think you're right. Nope. Not quite. Yes. Talk to each other. Not quite. Not quite. Not quite. You guys are both very close. Yeah. Good. Good. Not quite. Forgot about the negative. Yeah, you're good. Good, Sean. Good. All right, guys, just because we're running out of time here and I want to talk about your homework, close. Let's look at it. Your 2 points should have been 0, 1, 1, 4 to begin with, right? What is that negative out in front doing? Yeah, flipping it this way, right? Over the x-axis, so this is down here and this one's all the way down here. Then with each of those points, you have to go left 3 and down 2. 1, 2, 3, 1, 2. If I can count, 1, 2, 3, 1, 2, somewhere in there. Your asymptote is at -2. Your graph was, that's a very rough sketch, but something like that, right? Okay. All right. Homework. I don't want you to do all of it, but let me look at okay. So you're going to do on the front 1, 3, 5, and an 11. I know this is weird. Back 1. 2, 3. 7, 8. Okay, so we'll just do 5 on each side. If you need more practice, definitely do more of them, but that's what I'm checking next time. Remind me next time what I'm checking, okay? All right, guys. It says on your calendar that you have a quiz next time. You don't have a quiz next time, okay? Nope, I'm going to move it back today because we aren't through everything that's on the quiz, and we have a short period on Friday. So the weird schedule, early release / pep rally, chaotic day that it is. So, and depending on whether or not it rains, it'll be a different schedule.